Question 11 students. If triangle ABC is similar to triangle PQR in which AB is equal to 6 cm, BC is equal to 4 cm, AC is equal to 8 cm and PR is equal to 6 cm, then find the length of PQ plus QR. Here students, the two triangles are similar to each other. So that's why here we write that triangle ABC similar to triangle PQR. Okay, so now as the triangles are similar to each other, then their side ratios are equal. Okay, so that means AB divided by PQ is equal to BC divided by QR and here AC divided by PR. So now here students, we can substitute these given values that AB is equal to 6, PQ, that is PQ not given, that is we write as it is. Then here BC is a 4 cm, so I write 4. QR is not given, so I write as it is. Then AC is the 8 cm, so I write here 8, and the PR, that is the 6. So one by one I take the two ratios, that is first one I take these two ratios. 6 upon PQ is equal to 8 upon 6. So students, here that is the PQ is equal to 6 multiply 6 upon 8. That means 2 3s are 6, 2 4s are 6. Here 2 3s are and 2 2s are. So therefore 9 upon 2, that means 4.5 centimeter. Yes. So PQ is equal to 4.5 centimeter students. Okay. So I write here PQ is equal to 4.5 centimeter. So now here then students, the next one, that is I take these two equal ratios. That is the 4 upon QR is equal to 8 upon 6. So now cross multiply this. So QR is equal to 4 multiply 6 upon 8. So that means simplify it, 4 1s are 4 2s are 8, 2 1s are and 2 3s are. So QR is equal to 3 centimeter. So now here students, we have to calculate the PQ plus QR. So that means PQ is the 4.5 centimeter, 4.5 plus here QR is the 3, so that means 7.5 centimeter. So here PQ plus QR is equal to 7.5 centimeter. Question 12 students, in triangle ABC, if AD perpendicular BC and AD square is equal to BD into DC, then prove that angle BAC is equal to 90 degree. So now here student, first we draw the figure as per the given information, that is in triangle ABC, AD perpendicular BC. Okay, so I draw here, that is the BC. Okay, BC as the base, and then here the point A, and then draw the perpendicular here. So it is the AD perpendicular to BC. Okay, and then their given is also, that is the AD square is equal to BD multiplied by DC. So I write it here, that is the given. So from the figure we write the given, that is in triangle ABC, AD perpendicular BC, AD square is equal to BD multiplied DC. Then we have to prove that angle BAC is equal to 90 degree. Angle BAC is equal to 90 degree. So now here students, that we have to prove first, that is here the given is that AD square is equal to BD multiplied DC. So now AD square, that means we can write AD into AD, which is equal to BD multiply DC. Okay, so now here students, I write here AD upon BD and the DC upon AD as in the ratio form. Okay, and these ratios are equal. See here AD and BD, these ratios are equal and these are in the triangle ABD. And here DC and AD, here DC and AD are, these are the ratios are in the triangle ADC. So here students, that these side ratios are equal, and here we can say that the third angle ADB, here that from the given, that is AD perpendicular BC, and from that we can write angle ADB. Angle ADB is equal to or congruent to angle ADC. Okay, why these two angles are congruent? Because each angle 90 degree. Each angle is 90. Okay, so now here that is first and call it as the second one equation. Now from 1 and 2, that is from 1 and 2, we can say that the triangle ADB is similar to triangle ADC. Okay, is similar to triangle ADC, and as per the here this is the angle. Okay, this is the side, and this one is also the side. So that is the SAS similarity criteria. Okay, these two triangles are similar to each other. Okay, so now these two triangles are similar. Now here students, that as the two triangles are similar to each other, that means here the angle ABD, here angle ABD is equal to angle, this angle ABD is equal to angle ACD. Okay, these two angles are congruent, we can say congruent. And here also, that is BAD, angle BAD is congruent to angle CAD also. CAD also. Okay, so now here student, see that we have to finding out the angle BAC. So here I write angle BAC, which is equal to angle BAD plus angle CAD. Okay, but here we write here that BAD and CAD are equal. So angle BAD plus angle CAD. Okay, so now here two angle BAD plus CAD, that is two angle B, here at the place of here I write BAD. Okay, so two angle BAD. Okay, but what about the angle BAC? That is the BAC, that means the here these angles are 90 degree. So angle DBA and angle DAB are the 90 degree. These are the 90 degree angle. Okay students, so instead of that angle D, that is in triangle ABD, we can write angle ABD plus angle BAD plus angle ADB, which is equal to 180 degree. So now this angle is 90 degree here. Then we can say angle ABD plus angle BAD. So now angle ABD plus angle BAD is equal to 90 degree. Okay students? So now here that angle ABD plus BAD is equal to 90 degree. So now here students, that angle ABD is congruent to ACD. So instead of this I write angle ABD plus angle ABD is equal to 90 degree. So that means two angle ABD is equal to 90 degree. So that means students, angle ABD is equal to 90 upon 2, and then angle ABD is equal to 45 degree. So now here students, we got that angle ABD as a 45 degree. So now here students, that angle BAD also the 90 degree. So here we can write 2 multiply 45, that is equal to 90 degree. So angle BAC is equal to 90 degree. Okay, this part you can solve this part after this part students. Okay, after this part. Okay, so that's why we can say angle BAC is equal to 90 degree. Next example students, in the given figure QR upon QS is equal to QT upon PQ, and angle 1 is equal to angle Q, and we have to show that the triangle PQS is similar to triangle TQR. So first students will observe the figure, that which part is given, or we have to prove that. The first part, that is angle 1 is congruent to angle 2. Then the second one says that QR upon QS is equal to QT upon PQ. Okay, so these are the given part, and we have to prove that the triangle PQS, the smallest one triangle, is similar to triangle TQR, that is the biggest one triangle. Okay, we have to prove that these two triangles are similar to each other. So now here students, that we have to prove that triangle PQS is similar to triangle TQR. Okay, TQR, and that means students, we have to take these two triangles, okay, in triangle PQS and triangle TQR, and in these two triangles, which two components are congruent, which not two. If we get the angles, then two components are sufficient to show that these two triangles are similar. But here, that which two constituent or which three constituent or which components are congruent to each other. That's why first we take the support of our given. That first here QR upon QS is equal to QT upon PQ. Okay, so now here that students, that QR upon QS, we want the SR. How can we want the SR? QR is a total side. Okay, so here we apply the dividendo. Okay, here I write apply dividendo. Okay, apply dividendo, that means QR upon QS minus 1 is equal to QT upon PQ minus 1. So here Q1 minus QS upon QS is equal to QT minus 1 upon PQ. So that means QR minus QS, that means we get the SR. So SR upon QS is equal to that the QT minus QP, here PQ. Okay, PQ, that means the PT. So here we write PT upon PQ. So now here apply the invertendo. Okay, apply invertendo. Okay, now the invertendo, we have QS upon SR is equal to PQ upon PT. Okay, see here, that is a QS and SR. QS is in, see here, QS and SR. QS is in this triangle PQS, SR is in TQR triangle. Here PQ is in PQS triangle, and PT is in biggest one triangle TQR. So these two triangle ratios are, sides ratio are equal. So now here, and as well as the given here, that angle 1 is equal to angle 2. Okay, the angle 1 is in angle PQ, is in triangle PQS, and the angle 2 which is in the triangle that not in the biggest one triangle, but we say that the angle 1 is common in both the triangles, that triangle PQS and triangle PQR. So here we can say that students, that is the angle 1 here, that the angle 1 is, sorry, here QS upon SR is equal to, but not here SR, sorry, here not SR, see here QS, that is a QS upon SR is equal to PQ upon PT. Yes students, here not write this way. So now this is the ratio, and these ratios are equal. That means the converse of basic proportionality, that is the converse of basic proportionality theorem. Basic proportionality theorem. Okay, we can say that PS parallel to TR. PS parallel to TR. Okay students, now here PS parallel to TR, that means students, see this angle QPS is congruent to angle QTR. Here we say therefore angle QPS is congruent to angle QTR, and also that the angle QSP is congruent angle QRT. And what is the reason behind it? The reason is corresponding angles. Okay, these are the corresponding angles. Okay. If the sides are parallel to each other, then their corresponding angles are equal. So now here we write this angle as in triangle PQS and in triangle TQR. We can write the first component, that is the angle QPS is congruent to angle QTR, and the second one, that is the angle QSP is congruent to angle QRT. Yes, so now here it is sufficient that two angles are congruent to each other, and so that's why students, that by the AA property, that is by AA similarity criteria, okay, these two triangles are similar. That means here triangle PQS is similar to triangle TQR. Question, students. P is a point on the side BC of triangle ABC such that angle APC is equal to angle BAC. Prove that AC square is equal to BC multiply CP. So now here students, first we observe the figure, that as per the figure we have that P is any point on the BC. So now here that we also given is that angle APC is equal to angle BAC. This angle APC is congruent to angle BAC. Okay, and now here students we have to prove that AC square is equal to BC multiply CP. Okay, so that means here students AC multiply AC is equal to BC multiply CP. Okay, now AC we write here AC, that is AC divided by CP is equal to BC divided by AC. This way we can write the ratio. So now here we have to prove that AC square is equal to BC into CP. That means actually we have to prove that AC upon CP is equal to BC upon AC. This ratio are equal. Okay, so now here how can we gain that these ratios are equal? So here student, first see that AC and CP, the AC and CP are in the triangle APC. So we write here in triangle ACP. Okay, and this BC and AC, see here BC and AC, these two sides are in the triangle ABC. Okay, so now here we say that in triangle ACP and triangle ABC, the first component is that here APC here given that angle APC is congruent to angle BAC. Okay, is congruent to angle BAC, and we write here given. Okay, so now the second one component, is see that here the C is common. So here angle ACP is congruent to angle ACB. Okay, that is a common angle. Okay, so now we have two components are congruent. So here we say that therefore triangle ACP, here students, that ACP is congruent to BCA. See here A is congruent to here P is congruent to A. So here I write here A. So C is congruent to C. So that means the BCA. Okay. So triangle ACP is similar to triangle BCA because 1 to 1 corresponds. We write here the triangle BCA. So by which criteria? This is a AA similarity criteria. Okay. Criteria. So now here students, as the triangle ACP similar to triangle BCA, that means we can show that, we can write that their corresponding sides ratio are equal. So that means AC upon BC is equal to AC upon BC is equal to CP upon CA is equal to AP upon BA. Okay, Now here these two ratios are useful to us that to prove here. So AC multiply AC. So here AC multiply AC, which is equal to BC multiply C. So that means AC square is equal to BC multiply C. So that we have to prove here. Okay, we prove this. AC. Example students, question 15. The diagonal BD of a parallelogram ABCD intersects the line segment AE at the point F, where E is any point on the side BC. Now prove that DF multiplied EF is equal to FB multiplied FA. Now here students, first observe the figure carefully. That is the given. Which components are given here? There first, this is the quadrilateral. This quadrilateral is type of the parallelogram. So we remind that the opposite sides are parallel to each other. Opposite sides are parallel to each other, equal to each other. Okay. So now here then the line segment BD and A intersect at the point F here. Okay. And we have to prove this one. So DF and EF. So here DF and here EF. And here FB and FB. FB and FA. So now here these sides include. These sides are include in these two triangle students, that is DAF and BEF. So we choose these triangle students. Okay. So now here we can write here that in triangle DAF, and triangle BEF. Okay. In triangle BEF. Okay. We have to prove the two. We write the two components which are congruent. So how can we get the two components which are congruent? That is, see here, the DA here, DA parallel to BC, okay, DA parallel to BC, and here we say DA parallel to BE, okay. Now here, that means here students, the DAF here, this angle, DAF is congruent to this angle. Okay, because these two angles are alternate interior angles. Okay, so here we can write down the angle DAF is congruent to angle FEB. Okay, this one. Now, students, then the here, that is these two angles. See here. These two angles are also equal because the opposite angles. So angle DFA is congruent to angle EFB. Okay. So now opposite angles, and here the reason is the alternate interior angles. So now we have the two angles. So we write here in triangle DAF and triangle BEF. First one, angle DAF is congruent to angle FEB. And the second one, angle DFA is congruent to angle EFB. Okay. So therefore, triangle DAF is similar to triangle. So now here, carefully write down the 1 to 1 correspond. That is D, A, here F is for F. So here I write F. So now A is congruent to E. So I write here E. And then the D is congruent to B. So that is the similarity is triangle DF similar to triangle BF. And here the criteria is students, that is AA similarity criteria. AA similarity criteria. These two triangles are similar to each other. So now here students, their ratio will be equal, sides ratio will be equal. So here DA divided by BE is equal to here AF divided by EF, AF divided by EF, and here students DF divided by EF. Now here which two ratios we want, that's why our proof will be, hence we can be proved. So here DF and EF. So DF, here is the DF and here is the EF. Okay. Here FB and FA. Yes, these two ratios. So here AF multiplied BF is equal to AF multiplied DF. Okay, that means we write here DF multiplied AF is equal to FB multiplied FA. Okay, this way. So here it is proved. Example students, in the given figure, PA, QB and RC are perpendicular to AC. If PA is equal to X units, QB is equal to Y units and RC is equal to Z units, prove that 1 upon X plus 1 upon Z is equal to 1 upon Y. Okay, so now here AC is the base and PA, QB and RC are perpendicular to it. So now here students, first I show out they are perpendicular to here to the ACE. Okay, that perpendicular. Now here we have to prove that 1 upon X, 1 upon Z is equal to 1 upon Y. Okay, so now here 1 upon X and 1 upon Y. 1 upon X and 1 upon Y. Okay, so related with that the triangles, with respect to the triangle, we choose the first one, that is first step, that is taking the two triangles and that triangles are PAC, in triangle PAC and triangle here QBC. Okay, I choose this first step. Okay, so now here in these two triangles here I can see that the two angles are 90 degrees, so they are congruent. So angle PAC is congruent to angle QBC. Okay, angle QBC, because each angle 90 degree. Okay, the reason is each angle is 90 degree. Now the second one is that here that see here PCA and QCB. Okay, so the C angle is common here, students. So here angle PCA is congruent to angle QCB. And here we write the reason, that is the common angle. Okay, so now here we have the two components and that are congruent. So therefore we can say that triangle PAC is similar to triangle QBC, and by AA similarity criteria. Okay, now the students see, as the triangles are similar to each other, then their ratios, their sides ratio are equal. So here PA upon QB is equal to AC upon BC is equal to PC upon QC. See here, that is PAC is congruent to QBC. Okay, so we have these three ratios equal. So now here PA means X, now QB means Y, so X upon Y. AC not given, so write as it is, AC upon BC, and here the second one, PC upon QC. Okay, now here we choose the two ratios, X upon Y is equal to AC upon BC, and call it as the first equation. Now here students, that the next part is that we choose the two triangles, and that triangle include the Y and Z. Okay, so such a triangles are RCA and QBA. So here I write the second step, that is in triangle RCA and triangle QBA. Our first component will be angle RCA is equal to 90 degree and angle QBA is also equal to 90 degree. So here we write angle RCA is congruent to angle QBA. Reason is each angle 90 degree. Then the second component, that is the A is common here in both the triangles. Angle RAC is congruent to angle QAB. So I write here angle RAC is congruent to angle QAB. So I write here common angle. Okay. Now the two angles are congruent. So therefore we say that triangle RCA similar to triangle QBA. Okay. And the criteria, same criteria students, that is a AA similarity criteria. Okay. Then here students, as the triangles are similar, then that means their ratios are sides ratio are equal. So here RC upon QB is equal to CA upon BA is equal to RA upon QA. So now here student RC, see here RC is Z, QB is Y. So Z upon Y. So Z upon Y is equal to CA not given, BA also not given. So write down as it is CA upon BA. Okay, and is equal to RA upon QA. So but here we wanted to equal ratios because they are useful to solve this. So Z upon Y is equal to CA upon BA. Okay, so second one. So now here see students, that is from 1 and 2. Okay, that from 1 and 2 that we adding 1 and 2. Okay, the next process will be adding 1 and 2. Okay, so now here x upon y plus z upon y. Yes students, here now the AC upon BC. Okay, so now here that AC upon BC and here is the AC is the numerator position. So we here inverted law, apply the inverted law here. Okay, so here I do that y upon x is equal to BC upon AC here. Okay, and here also student that at the reciprocal position we want the AC as the reciprocal position, then y upon z is equal to BA upon CA. Okay, I call it as same. So adding 1 and 2. Okay, that y upon x plus y upon z is equal to BC upon AC plus BA plus CA. CA means AC. So I write here C. Okay, so now here that these ratio I do it as it is, right as it is. Okay, y upon x plus y upon z. Now here the BC, here AC denominator is same, so AC, and here BC plus BA. Okay, BC plus BA. So now here BC plus BA, that means the AC students. Okay, that means the AC. So here AC upon AC. So here now here y upon x plus y upon z, and here AC upon AC, that means the 1. Okay, students, I do here the next steps, that is the y upon x plus y upon z is equal to, that is a 1. But here before that I write here the step that is a cross multiplication step here. I do here. So that is a yz plus xy upon xz. Okay. So now here yz plus xy upon xz. So which is equal to 1. So yz plus xy is equal to xz. Cross multiply this one. Okay. And then here dividing both the sides. Dividing both the sides by xyz. Dividing both the sides by xyz students. Very easy process. Very easiest method, and you can solve it very sufficiently, very efficiently you can solve it. Okay, so understood what is the method, how which other step includes in this such a type of the example. So now we are dividing both the sides by x y z. So yz get cancel. So here 1 upon x plus students xx get cancel y by x. So 1 upon z, which is equal to here xx and zz cancel. So 1 upon 1. So now here students see here the two proof. Our two proof is this one, and here hence it is proof. So student, such a way the examples by looking we can say it is a very hard question. But no, it is not very hard question. Step wise you can go out the step by step solution and then you get the answer.